So let's take a look at integration by trig substitution. So whenever you're trying to find the area under a circle or an ellipse, you might come across three different types of expressions under an integral. So the first one could be the square root of a squared minus x squared. And remember, a is just a constant. The second one could be the square root of a squared plus x squared. And the third one could be the square root of x squared minus a squared. And so when you find the square root of a squared minus x squared under the integral, or inside the integral, you're going to use a substitution where x is equal to a times sine of theta. When you have the square root of a squared plus x squared, you're going to use a substitution x equals a tangent of theta. And then when you have the square root of x squared minus a squared, you're going to use a substitution where x equals a secant of theta. And the reason why we do this substitution is so that we can get rid of the square root and make it easier to integrate. So for number one, we have the integral of this 1 over x squared times the square root of x squared minus 9. So realize that you can't really do u substitution, partial fractions, long division, or any of those type of methods. So trig substitution is kind of like your last option. So notice we do have here the square root of x squared minus a squared. It's in that form. So if a squared is 9, then a is going to be equal to 3. So when it's in this form, the substitution we're going to use is x equals a secant theta, or in other words, 3 times secant of theta. And so keep in mind that while we need to substitute in x as well, we also need to find what dx equals. So dx is simply just the derivative of our x equation. So if x is 3 secant theta, dx is going to be 3, and the derivative of secant theta is secant theta tangent of theta, d theta. And so now we can go ahead and substitute in to the integral. So we get the integral of 1 over, now we have x squared, so 3 secant theta squared, or 9 secant squared theta, times the square root of, once again, 9 secant squared theta minus 9. And then we obviously have multiplying by dx, and dx is 3 secant theta times tangent of theta d theta. And I'm going to go ahead and move the 3 secant tangent theta up to the numerator here. Okay, so now in order to simplify, I'm going to first simplify the radical. So I'm going to start by factoring out a 9 here. So we get 9 times secant squared theta minus 1, the square root of the entire thing. Now, the square root of 9 is 3, so I can bring that outside of the radical. And so we get 3 times the square root of secant squared theta minus 1. Now the trig identity we need to use is that secant squared theta minus 1 is equal to tangent squared of theta. So I'm just going to go ahead and replace that with tangent squared. So we're going to end up getting 3 times the square root of tangent squared of theta. And so the square root of tangent squared is obviously just 3 tangent theta. So with trig substitution, we're able to get rid of the radical. So now I'm going to rewrite the integral here. We get the integral of 3 secant theta tangent of theta over 9 secant squared theta, and we simplified the square root to 3 tan theta. So I'll rewrite it as multiplied by 3 tan theta d theta. So now the tangents will cancel, the 3's will cancel, and one of the secants will cancel. So we're left with the integral of, well, 1 over 9 is a constant, so we can bring that outside, and then we get 1 over secant of theta, d theta. Now 1 over secant is the reciprocal, so cosine, so we get 1 over 9 times the integral of cosine of theta, d theta. And so now to evaluate the integral of cosine is just sine, so the answer will be 1 over 9 sine of theta plus c. So now we have it in terms of theta, but we need to change it back in terms of x, because the original integral was in terms of x. So what we need to do here is make a right triangle and call one of the angles theta, and we have a right triangle here, 90 degrees. So earlier we said that x is equal to 3 secant of theta. So if we isolate secant of theta is equal to x over 3. Now secant of theta is the reciprocal of cosine, so if cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. So we have the hypotenuse as x and the adjacent as 3. Now we need to find this side, let's just label it b, using the Pythagorean theorem. So if a squared plus b squared equals c squared. Let's isolate b. So b is going to equal the square root of c squared minus a squared. So if c is x, then b is going to equal to the square root of x squared minus a, which is 3. So a squared is 9. So that's what b is going to equal. Now, when we evaluated the integral, we had to find what sine of theta is. So sine of theta is opposite over hypotenuse. So our b value is going to be the square root of x squared over 9 over x. So that is what sine of theta is equal to. So I can go ahead and rewrite the answer as 1 over 9 times sine of theta, which is the square root of x squared minus 9, over x plus c. And so then I can combine it and rewrite it as square root of x squared minus 9 over 9x plus c as the final answer. So now for number 2, we have the integral of x cubed over the square root of x squared plus 9. And so notice we have it in the form, the expression is in the form of the square root of x squared plus a squared, where if a squared is 9, which means a is going to be equal to 3. So the substitution we're going to use is x equals a tangent of theta, or 3 tan theta. And if x is 3 tan theta, then dx, the derivative, is equal to 3 secant squared of theta, d theta. So when I go ahead and substitute these values, we get the integral. Now, if x is cubed here, 3 tangent theta cubed is going to be 27 tangent cubed of theta over the square root of x squared, so in this case it's 9 tangent squared of theta plus 9. And then dx is equal to 3 secant squared theta d theta. And so let's go ahead and simplify the radical first. So I'm going to go ahead and start by factoring out in 9. So 9 times tangent squared theta plus 1. And so the square root of 9 is 3. We can obviously bring that outside the integral. So we get 3 times the square root. And what we're left with is tangent squared plus 1. But remember the trig identity, tangent squared plus 1 is equal to secant squared of theta. So we're going to use that to sub it in. So the secant squared of theta. And so the square root of secant squared is obviously just secant of theta, so we get 3 secant of theta. So when I rewrite the integral, we'll get 27 tangent cubed of theta over what we have simplified the radical down to is 3 secant theta multiplied by 3 secant squared of theta, d theta. So the 3's will cancel, one of the secants will cancel, and so we're left with the integral. And 27 is a constant, so I can bring that outside the integral. So we get 27 times the integral of tangent cubed of theta times secant of theta, d theta. And so because we have a tangent to an odd power, whenever a trig function is to an odd power, we can actually use a trig. So I'm going to separate tangent cubed into tangent of theta times tangent squared of theta. And so we're going to use the same trig identity where tangent squared plus 1 is secant squared. So secant squared theta minus 1 is tangent squared of theta. So I'm going to rewrite it as tangent of theta times secant squared of theta minus 1. And then I can go ahead and distribute, or actually I don't need to distribute, I can multiply it by our other secant of theta here. And so when I rearrange it, we get secant squared theta minus 1 times secant of theta tangent of theta. And so that's under the integral here. So now remember there is a 27 out here as a constant, so I'll bring that down. And then what we can use here is simple u substitution. So I'm going to make the u equal to secant of theta. So up here, if u equals secant of theta, then du, or the derivative, is going to be secant of theta tangent of theta d theta. So then d theta is equal to du. When I divide over secant tangent, we get du over secant of theta tangent of theta. So when I plug this in for du, or sorry, for d theta, let's go ahead and erase this. So I'm going to go ahead and plug this in for d theta. Notice the secant tangents will cancel, and so we're left with, and our u is obviously equal to secant squared, so I'm going to substitute that for u. We'll get 27 times the integral of u squared minus 1 du. And so when I evaluate, the integral of u squared is just u cubed over 3. And the integral of 1, or negative 1, is negative u. And then when I go ahead and multiply, we'll get 27 u cubed over 3, which is 9u cubed, minus 27u. And so once again, we said our u is equal to secant of theta. We made our u secant of theta, so I can go ahead and substitute that back in. So we get 9 secant of theta cubed minus 27 secant of theta. So now there's one more thing left. We need to turn it back to x variables. So we said that x is equal to 3 tan theta earlier. So if we draw a right triangle here and make this value theta, if x is 3 tan theta, then tangent of theta is equal to x over 3. Meaning that opposite adjacent is x over 3. So opposite is x, adjacent is 3. Now in order to find what, let's just call this c, the hypotenuse is, once again we can use the Pythagorean Theorem. So a squared plus b squared equals c squared. So 3 squared is 9 plus x squared equals the hypotenuse squared, which means that c is going to equal to the square root of x squared plus 9. So I'm going to go ahead and rewrite c as the square root of x squared plus 9. And so when we evaluated the integral, we came up with secant of theta. So we need to find what secant of theta is equal to. Once again, secant is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, secant is going to be hypotenuse over adjacent. So secant of theta is equal to the square root of x squared plus 9 over 3. So we're going to get, when I substitute that in for secant of theta, we'll get 9 times the square root of x squared plus 9 over 3, all cubed to the power of 3, minus 27 times secant theta, once again, square root of x squared plus 9 over 3. So when we take this to the third power, this is basically x squared plus 9 to the 1/2, and 1/2 to the third power is 3/2. So we get x squared plus 9 to the 3/2 power. Now 3 cubed is 27, and so we have 9 over 27, which just simplifies to 1/3. So I'll just put 3 on the bottom. And then we have minus 27 divided by 3 is obviously 9. So we just have 9 times x squared plus 9 to the 1/2 power. And then we need the plus c. And so that is the final answer. So now for number 3, we have 1 over x squared times the square root of 25 minus x squared dx. So now we're in the form of the square root of a squared minus x squared. And so if a squared is 25, that means a equals 5, which means the substitution we have to use in this case is x equals a sine of theta, or in other words, 5 sine theta. So if x is 5 sine theta, dx is going to equal to 5 cosine theta d theta. And so when we substitute in, we'll get the integral of 1 over x squared, so 25 sine squared theta, times the square root of 25 minus 25 sine squared theta. And then obviously dx is equal to 5 cosine of theta d theta. So when I simplify the radical, once again, like all the other problems, we're going to factor out the a value, so 25, or the a squared value, so 25 times 1 minus sine squared theta. So 1 minus sine squared theta is obviously cosine squared theta using trig identities, and the square root of 25 is 5. So we're going to end up getting 5 times the square root of cosine squared. And the square root of cosine squared is obviously just 5 cosine theta. So when I rewrite the integral, I get the integral. I'm just going to go ahead and move that up top to the numerator. So we get 5 cosine of theta over 25 sine squared of theta times, when we simplify the radical, we got 5 cosine theta. We get 5 cosine theta and then d theta. So realize the 5's will cancel, cosines will cancel. And so we're left with 1 over 25 is a constant. I can bring that outside the integral. And we get 1 over sine squared theta. Now, when I reciprocalize sine squared, the reciprocal of sine is cosecant. So we get 1 over 25 times the integral of cosecant squared theta, d theta. And so the integral of cosecant squared, remember, is negative cotangent of theta. So we have negative cotangent theta, d theta. And so, or actually the d theta goes away, my bad. So then we'll get negative 1 over 25 cotangent of theta plus c. So once again, we need to substitute theta for x now. So if we make the right triangle here, make this our theta value, we said earlier that x equals 5 sine of theta. So if we isolate sine of theta, it is going to equal x over 5, meaning opposite, hypotenuse is sine, so opposite is x, hypotenuse is 5. So if we solve for, let's say, a now, using the Pythagorean Theorem, a squared plus b squared equals c squared. So then a is going to equal to the square root of c squared minus b squared. Or in other words, the hypotenuse squared minus x squared. So a is going to equal to the square root of 25 minus x squared. Now we need to find what cotangent of theta is. So if tangent of theta is opposite over hypotenuse, then cotangent of theta, or sorry, opposite over adjacent is tangent. So cotangent would be adjacent over opposite, meaning we would take the a value over the opposite x. So cotangent of theta is equal to the square root of 25 minus x squared over x. So if I go ahead and substitute that in, we'll get 1 over 25, negative 1 over 25 times cotangent of theta, which is equal to this. So we get the square root of 25 minus x squared over x, and then plus c. And so to simplify one more time, just go ahead and merge the fractions together. We'll get negative square root of 25 minus x squared over 25x plus c. And that is the final answer.